Hello, my name is Giles Hammond and I have been a member of the Royal Society of Edinburgh Young Academy of Scotland since 2011. I'm a lecturer in gravitational physics at the University of Glasgow and currently work in the Institute for Gravitational Research. My typical day is split between teaching undergraduate and postgraduate students, undertaking administration tasks for the School of Physics and Astronomy, and carrying out research at the forefront of our current knowledge. My particular area of research focuses on building hardware for an international network of detectors to search for gravitational waves. These waves were predicted by Albert Einstein in 1915 and are expected to cause objects to stretch and shrink by a tiny amount. As a physicist, my day job requires a wide range of skills including oral and written communication, time management, numeracy and problem solving, computational programming, experimental design, fabrication and debugging. In particular, numeracy skills are important for data analysis, using mathematics to solve or simplify problems, and developing quick order of magnitude estimates of quantities. Using simple time periods, I can work out how long a journey will take, the speed travelled at, or distance covered, using my knowledge of the link between time, speed and distance. Here are two examples which I typically use in my daily work. Example 1. Sometimes I teach in our astronomy labs at 2 o'clock on a Tuesday afternoon. The lab is located approximately 4 miles from my office at another University of Glasgow campus location. I therefore need to estimate at what time I need to leave so that I can arrive in sufficient time. My journey comprises 3 parts. I need to walk to the car for 5 minutes at the start of my journey, travel by car, and then walk for 2 minutes at the end. The car journey is through the city and thus I cannot travel faster than 30 miles per hour. Given the fact that there are traffic lights, pedestrians and other cars, I would estimate my average speed is 20 miles per hour. The total time taken for the car journey is given by time equals distance divided by speed. In this example, the units of distance are miles and the units of speed are miles per hour, so the time will be determined in hours. We must always use consistent units. This equation is correct as it states that travelling faster will shorten the total journey time. Plugging in the numbers gives a driving time of 4 divided by 20, which equals 1/5 of an hour. This is equal to 12 minutes. Adding up all of the contributions gives a total time of 5 plus 12 plus 2, which equals 19 minutes to get to the laboratory. I therefore leave at 1:41 on a Tuesday afternoon. My experience has shown that on 95% of the times, I arrive on time. On the 5% of times when I do not arrive, it is usually because there is more traffic, my speed is slower, and thus my driving time is increased. In example 2, I give an undergraduate lecture course which focuses on the solar system. A question which often arises is how long does it take for the light to travel from the sun to the earth? Light has a very high speed, equal to about 300 million meters per second. This is much faster than driving, and the reason why the room light appears to turn on immediately when you press the light switch. But the distance of the sun to the earth is also very large and approximately equal to 150,000 million meters. Thus, the time taken for light to travel this distance is given by time equals distance divided by speed. In this example, the units of distance are meters and the units of speed are meters per second, so the time will be determined in seconds. These are big numbers which can be difficult to deal with. Both distance and speed include a factor of 1 million, so we can ignore this as we are dividing the quantities. The time for the light to travel from the sun to the earth is then 150,000 divided by 300, which equals 500 seconds. This is about 8 minutes. Unlike driving, there are no traffic jams in space, so light always travels at a constant speed. Numeracy matters to me because by using simple time periods, I can make accurate estimates of how long it will take me to make a journey, and thus allow me to manage my time accurately. I can also use time periods to demonstrate important concepts in physics teaching, such as the time that it takes light to travel between the Earth and objects including the Sun, other stars and galaxies in the universe.